To Tech Diet, let's dive into our today's problem, maximum number of achievable transfer requests. It says we have n buildings. Each building has some employees and there will be a request array given to you which says a person from building A wants to move to person to building 2. So all buildings are full. We need to make a change. Only those requests will be accepted where the net employee transfer rate is 0. That means the number of employees that are leaving is equal to the number of employees that are moving in. So let's start with an example. So let's just check this test case. So we have this. It says person from building 0 want to move to building 1. Person from building 1 wants to move to building 0. So that's they are going to transfer. So let's keep track of the original persons in per building. So when we say 0 to 1, that means building 0 have at least one person, right? So we have, let's say, 3, 4, and the corresponding original would say on the 0th building I encounter a transfer from 0 to 1. That means there was person in 0th building. Then from 1 to 0, that means there was person available in 1th building. Then again 0 to 1, that means there were one more person was available. Then from 1 to 2, then from 2 to 0, then from 3 to 4. So in 4th building we don't have any, so that is our original employee list or employee list in the respective buildings. So we'll then, if we make these transfers, we'll get with like from 0 we reach to 1, and from, let's say, initially all are 0, and then we make that move from 0 it go to 1, from 1 it go to 0. So we'll update this transfer from 0 to 1. Again we move to building 2, then from 1 to 2, from 2 to 0, from 3 to 4. So this will be our moved employee list. So all these moves will be valid in case we land up in the original list, right? Because that's what they said, the net change in the employee transfer should be 0. So yeah, this could be one approach where we'll say how many, okay, we'll pick this transfer, we'll pick this transfer and we'll compare whether the original employee list is equal to the moved employee list. If that is the case, then we know that is the valid transfer. So we'll make that count, and whatever the maximum count of all the distributions will send it as our answer. So let's see how much constraints that we have. So we have total 16 would be the array length. So this could be part of the answer or this could not be. So each transfer will have two choices, either that could be included or excluded. So based upon that it will go to 2 raised to power 16, which should not be much issue. Let's try to implement this approach if it works. So what we are going to do is uh, we'll create a help function. We'll pass it to our requests array. We'll start with uh, checking the first transfer request. So we'll call this function request 0th, check whether we want to include 0th one. We do want to include, so for that this is our moved list. Let's name it as our after list. So for that we need to create one original list and one after list. Each will have a size of n rooms, and after we made the transfer we'll end up here. So if we are considering this room, that means our originally we will have in that request at index I at 0th room, so the person was there and employee was there, and after we make him transfer to the index next one, we'll increment that count, and we call this helper function again with the next transfer request. If that is not the one, we can say okay, we need to remove this guy, we need to remove this guy, and here we can keep track like how many requests does this current sequence had, and after that we can just do minus minus. So this will be like include the request, this is like exclude the request, so I'm going to call it again. So this is exclusion and this is inclusion. So how long do you want to do it? Unless or until we have this less than the total number of requests. Do we have any specific? So yep, and then we can say else. We know else will say if this is a valid transfer, are this a valid request? So if it's a valid request, we can say our max count will be max count and the current count in our hand. So we'll say we'll keep a track of max count as well, also count as well. So now let's just call trace out this function. So we'll have a valid request. For this we just need to say if my original is equal to the valid one, right? So here I can say whatever the number of original dot length I plus plus, if by any chance original I is not equal to my after I make the transfer, we want to break it. Okay, let's just return false here. We can change it back to boolean, then we can say return true. So yeah, it's a valid request. Then we'll keep on track what is the maximum so far, and once that is done we can return our max count. Let's try to see. So let's call requests dot length. Okay, it's original. Looks like this is working. Let's try to hit submit. Yep, it accepted. So that was our approach. Either the transfer could be part of the original maximum list or it cannot be. So we'll perform the backtracking, we'll include it once, we'll exclude it once, we'll keep track of all the requests whether it's part of the final answer or not, and if it's a valid request we'll compare, okay, how was it if there's a valid piece in my hand. So do I added this, I add this, so I just consider one this force. What after considering this force, do my original building will stay exactly how it was, the number of employees stay the same. If it not, we'll say it's not a valid split, we can't include it in our maximum. We'll keep track of the corresponding numbers that we have, number of transfer requests that we approve at the current instant in our backtracking. So yeah, that's about it. Thank you.